We're asked if the given vectors or vectored valued functions are linearly independent, and we're asked to justify. Recall that vectored value functions x1 through xn are linearly independent when c1 times x1 plus c2 times x2 all the way through plus cn times xn equals a zero vector has only the solution c1 equals c2 all the way through cn equals 0 for all values of t. To check for linear independence, let's check the vector equation c1 times x1 plus c2 times x2 plus c3 times x3 equals the zero vector. And now let's write the corresponding system of equations. We have c1 hyperbolic cosine t plus c2 e to the t plus c3 e to the negative t equals 0, as well as c1 plus c2 plus c3 equals 0. Because the first equation involves the hyperbolic cosine function, as well as e to the t and e to the negative t, we do need to recall hyperbolic cosine x is equal to the sum of e to the x and e to the negative x divided by 2. If we multiply both sides by 2, we have 2 hyperbolic cosine x equals e to the x plus e to the negative x. Using this equation and the first equation in our system, if we let c1 equal 2, we have 2 hyperbolic cosine t, which we know is equal to e to the t plus e to the negative t. And because we want the sum to be equal to 0, if we let c1 equal 2 and c2 and c3 equal negative 1, we have 2 hyperbolic cosine t minus 1 e to the t minus 1 e to the negative t, which does equal 0. This also satisfies the second equation, where c1 plus c2 plus c3 equals 0 would be 2 plus negative 1 plus negative 1, which is 0. So because we found a solution where c1, c2, and c3 are not all 0, we now know the vectored valued functions are linearly dependent. Notice in this case, we're not able to form a matrix where the columns are the vectored valued functions and then find the determinant, because the matrix would be a 2 by 3 matrix, and we know to find the determinant, the matrix must be square. I hope you found this helpful.